Hi guys, I also wanted to do another walkthrough of a potential an example Hess's law problem that was different from the homework. I apologize for the background noise, my blinds are kind of flopping around. Here's the original equation, okay, 5C plus 6H2 yields 1 mole of C5H12. Now, we want to find out the heat of formation of this guy right here. There's no other information. All we know is how many moles of each of the reactants and each of the products we have. Where do we get, right? I know I've written all over this, but we have this equation, we have this equation, and we have this equation, okay? Where do we get them? Well, a standard table will usually be provided with basic reactions, okay? So we pull those basic reactions which have the components or some variety thereof of the reactants and products in our original equation. So this is a standard equation with a known heat of formation, right? Carbon plus oxygen yields CO2. The heat of formation is negative 393.5 kilojoules per mole. We also know that H2 plus half a mole of O2 yields water, H2O, and the heat of formation for that is minus 285.8 kilojoules per mole. Okay, and then we have, not per mole, that would be the, no, sorry, it is per mole rather, so it should be in there. And then we have C5H12. So far, right, we have the C, we have the H, and we have the C5H12. So C5H12 plus 8O2 yields 5CO2 plus 6H2O with a heat of formation of negative 3,536 kilojoules per mole. So we know all this in blue. Those have all the right components, but in this case, this is not on the right side, right? It needs to be on the product side, not the reactant. And here, the carbon and the hydrogen are on the right side, but not in the right proportions. So here we want to mark the coefficient and change the whole equation by whatever factor that particular term of interest has been multiplied by. So in our equation, there are 5 of the solid carbon graphite atoms. So we want to multiply this entire equation, C plus O2 yields CO2, by 5. So that becomes C5, 5C plus 5O2 yields 5CO2. If we're going to multiply the whole equation by 5, we also have to multiply the heat of formation by 5, which gives us negative 1,967.5 kilojoules per mole. Here, right, we need 6 H2, so we multiply this equation by 6, which gives us 6H2 plus 6 divided by 2, which is 3 oxygens, plus 6H2O. And likewise, we multiply that heat of formation by 6 to give us negative 1,714.8 kilojoules per mole. Down here, we don't need to change it. It's 1 and 1, but we need to change it from the reactant side to the product. So this equation already had a negative heat of formation. We're going to flip it, right, which means we're going to make this positive. We're going to change the sign. So then we come down here, and I want you to take all the reactants that we came up with and put them on this side. Excuse me, I apologize here. This is the equation we want. So we want this equation right here, this equation right here, and this one. This is the one we're using right after we flipped this one. So we need 5C, 5O2, 6H2, 3O2, 5CO2, 6H2O, all on the reactant side, which we have here. And then on the product side, we need 5CO2, 6H2O, 1 C5H12, and 8O2, which we have over here. The 5O2 plus the 3O2 adds up to 8, right? And we have 8 on the product side, so those cancel out. We have 5O2 on the reactant side, and 5CO2 on the reactant side, 5CO2 on the product side, so those cancel out. We have 6 waters on the reactant side and 6 on the product side, so those cancel out. So we're left with 5 carbons plus 6 H2s yields C5H12, right? That's our original equation. So if that works, now we can take all the heats of formation for those individual equations and add them up, right? So we have minus or negative 1967.5 plus negative 1714.8 plus, remember we flipped this one, positive 3,536. We add them all up and we get an overall negative heat of formation, 146.3 kilojoules per mole, which means that when we mix solid graphite carbon with hydrogen gas to make this, it's an exothermic reaction, right? The system actually loses energy.